Here's another scenario on how you can use your Henderson-Hasselbalch equation to prepare a buffer. This time, we have one component that is in solution form and the other component is in solid form. Let's read the problem. What mass of sodium acetate must be dissolved in 0.300 liter of 0.25 molar acetic acid to produce a solution with pH equal to 5.09? Now take note, there is a very important assumption given in this problem. So we should assume that the volume of the solution, once we add the solid sodium acetate, will not change appreciably. So it will remain very, very close to 0.300 liter. So how do we solve this problem? So again, we identify our given. Let's write first our Henderson-Hasselbalch equation. So as a practice, just solving a lot of problems is a very good practice. And actually, if you solve a lot of problems, it will really help you because you will encounter different types of problems. So it's conjugate base, so that will be acetate over the weak acid, which is acetic acid. So our target pH is 5.09. So that will be our pH value. And again, we are given the Ka. So we can get the pKa, which is equal to 4.74. And then we have the concentration of our weak acid component, which is 0.25 molar. So again, because we assumed that the volume will not change, the concentration remains the same. So now you will be able to compute for the concentration of acetate in the buffer from this equation. So the value that you will get is 0.559675 molar. So I added a few digits just to increase the accuracy of my value, but not too much. Okay. So now we have the concentration. And we use this as the basis to get the mass of sodium acetate. So how many grams of sodium acetate will give us this concentration of acetate in the final buffer solution? So again, our basis is this concentration, 0.559675 molar or mole per liter. Again, this refers to the moles of acetate. We multiply this by the final volume of the solution, which is 0.30000 liter. And then again, we consider that there is 1 mole of acetate in 1 mole of sodium acetate. So I'm just showing this to make things clear. And finally, we use the molar mass of sodium acetate, which is 82.0343 grams per mole. And solving for this, you will get a value of 13.77 grams. So the scenario is you have 0.3 liter or 300 ml of 0.25 molar acetic acid solution. And then to this, you will add 13.77 grams of sodium acetate. So you dissolve this in this solution, you stir it until everything dissolves. Check the pH. Okay, so if it's exactly 5.09, then you're done. But if it's not, you again use uh, hydrochloric acid or sodium hydroxide to adjust the pH until you reach your target value, which is 5.09.